So let's talk about frequencies. This is an arbitrary sinusoidal steady state signal. Whenever you see a number multiplied by t, that number that's multiplied by t, this thing, is the frequency in radians per second. And we abbreviate that as a symbol. We write that as a symbol as lowercase omega. There is another type of frequency that is commonly used with sinusoids. It's even more common than radians per second, and that's called hertz. You've heard of that before. Hertz says how many cycles there are in a second. So I'm going to create a completely different signal here. And instead of multiplying it by t, we're going to multiply this by 2 times pi times t. So if we have a number here, say 120 times 2 pi t, we'll give it some sort of arbitrary phase here. Maybe it's equal to, the signal is equal to pi over 4. It's just completely different than the one above. Now, because this is multiplied by 2 pi t, this is the frequency measured in hertz. So this waveform, it has 120 cycles every second. And compare that with what its angular frequency is in omega, in radians per second, which of course is everything times t. So its angular frequency is 120 times 2 times pi, and its frequency is 120. This is also called angular frequency. From the way that we've defined both angular frequency and frequency in hertz, you can see that the relationship between the two of them is one is 2 pi times the other. Specifically, angular frequency is equal to 2 times pi times the frequency in hertz. So that's an important relationship that you should know. Another important relationship that you should know is the relationship between the time period, t, and the frequency. And they're reciprocals of each other. So if the frequency of the second example is 120 hertz, then that means one time period, is 1 over 120th of a second. All right, so the time period measures how long it takes. Physically, it measures how long does it take from one crest to another. That's its time period, and it's measured in seconds. And of course, that we just said is equal to 1 over whatever its frequency is in hertz. And you know how to extract that frequency in hertz, either by writing it in this form or by noticing whatever's multiplied by t is its omega, is its radian frequency, and then just divide that by 2 pi to get its frequency in hertz. Let's do a quick example. Find the time period of 2 times cosine of 3 pi plus pi over 2. So to do that, we'll firstly extract the radian frequency here, and that tells us that omega is equal to 3. Using our first formula, we can see that the frequency in hertz is equal to omega over 2 pi. So for this particular example, it would be equal to 3 over 2 pi. And then we know that our time period is equal to 1 over our frequency. So it is equal to 2 pi over 3 seconds. And that's the answer. Although it wasn't asked, you can also say that the amplitude of this waveform is 2, and its phase is pi over 2. Radians. Okay, we've pretty much discussed everything about frequency here. Let's move on to phase.